All right, stats. Here we are for your notes video for Monday, November 20th, 2023. And we are brought to you by two of our favorite things in the classroom. Number one, running. Yes, get the international bestseller, Lore of Running. I know it's on your Amazon wish list. And Outlive, longevity, baby. So obviously we love Andrew Huberman, and you know who he loves? Peter Attia. So let's get on Attia's Peter Attia train there, folks, when you're in college. Here's what I need you to do first. So on page 17A, I was talking about this the other day. We had finished this first, well, we had made the Venn diagram on the first example. We're going to finish that tomorrow. But I need you to change this on page 17A in your notes. Probability of A needs to be this, probability of B needs to be this, probability of C needs to be this. All right, I need you to change those or else we've got an issue. All right, 17A, change those numbers. We'll talk about how we get the other numbers then. So we're going to look at page 19 and 20. I'm going to tell you a few things on your homework, and then you might have a surprise at the end, okay? So hopefully you're watching at the time we're supposed to, which is in class. So on page 19, you're going to want to write this on a zebra sheet. This is chapter 12, notes continue. All right, so it says an instant lottery game gives you a probability of 0.02 of winning on any play. Plays are independent of each other. If you play 3 times, the probability that you win on none of them, is probably pretty high, folks. Don't play lottery. Don't waste some money. Put money in your kids' college funds instead, all right? Or buy books. The probability of X is 0.02, so the probability that you don't win any of them is the probability of losing 0.98 raised to the third power. There you go. Okay, check, we did that. Then it says probability that you win on one or more in the previous exercise is what? So X is the event of winning an instant lottery. Okay, so you want to know the probability that X is greater than or equal to 1, which is always 1 minus the probability that X is 0, which we found in the previous example. So 1 minus 0.941. Again, pause this. This is the third video I'm making here today, so I'd like to be done. Pause this if I'm going too fast. All right, so on 1219, an athlete suspected of having used steroids is given 2 tests that operate independently of each other. Test A has probability of 0.9 of being positive if they've been used. So that means 0.1 of a false negative. Test B has probability of 0.8 of being positive if steroids have been used. So that's a 0.2 chance of a false negative. That means it says negative, but steroids were used. So it wants to know what's the probability that neither test is positive if, in fact, steroids has been used. So what is the probability of getting 2 straight false negatives? Probability 2 false negatives. 0.1 times 0.2, 2% chance. So that's 1 out of 50. You test 50 people like this, one of them is going to get 2 false positives. All right, then the next one, we're talking about some deaths of despair. That's what they're called, folks, deaths of despair. I think alcoholism is put in there as well, amongst, there might be a few other things. But anyway, for 20 to 24-year-olds, okay, here we go. So I've made the table again. You might want to do that. Make the table. Pause this. Make the table. You have time. Your little surprise here at the end is not that long. You guys got 44-minute classes, even with the long breakfast here. You got plenty of time. So female, male. Let's first off, how many accidental deaths? How many deaths by homicide? How many deaths by suicide? How many males? How many females? This column and this row both add up to 14,099. So what is the probability? 1220 just says, what is the probability that the victim is male? Just choose any violent death. So the probability of a male here that died because of violent death, any of these is 0.814. Now we have some conditional probability. So 1221 says, it literally says, the conditional probability that the victim was male given the death was accidental. So accident needs to go second. So what's the probability that given an accident, the person that died was a male? Or the probability that you select a male given the death was accident. So accidents, the number of accidents needs to go south, and the intersection of males and accidents, which is this number, needs to go north in the numerator. Now, 1222 looks like the same question, but the ordering is very, very different, and that matters. The conditional probability that the death was accidental given that the victim was male. So find the probability that the death was an accident given that the person that died was a male. So what is different? The denominator is always the given. So the denominators are different here. There were almost 11,500 males that died, okay? But the intersection remains the same. So if I have probability of A given B, whatever I said, the given is always the denominator, but the intersection, A intersection B or B intersection A, stays up top. So the intersection of accidents and males is still that 6457 number. The numerator remains the same in these two questions. That's something we'll just see more of. All right. So 1223 says, let A be the event that the victim of violent death was a woman, and B be the event that the death was a suicide. The proportions of suicides among violent deaths of women is expressed as what? So they want to know, it literally says, the proportion of suicides among the deaths of violent women. Okay, so what is the probability of picking a suicide given that the woman died is what they're asking. Okay, they said A was woman, they said B was suicide, so this is the probability of B given A. Okay, so let's talk about that. So this is conditional probability. So the probability of A given B, so B's in the denominator. Okay, the given is always in the denominator. And up top is the intersection. Okay, you don't really need to have that formula, all right? Because I'm just going to give you data, and you're just going to be able to look. Okay, I need to look here, and then the intersection is here. That goes in the numerator. That is technically the formula for conditional probability. All right, so conditional, because we'll talk about this again, probability formula. So, I mean, you know, like we had here, the probability of B given A would be, all right, the intersection. The given is down below, and the intersection is still the same thing. Probability of finding the intersection of B and A is the same thing as A and B. All right, but this is different. That's 1223. Then we're going to look at 1224 here. I set it up this way. It didn't ask for a Venn diagram, so we don't need to do that. So A's a woman, B's never married. So the intersection would be a woman who is never married. Let's write that down. So the probability of finding a woman or someone that was married or both is there it is. Probability of finding a woman plus never married minus the intersection. So this would be a formula we do have to have memorized because it is not on that SIU final exam formula sheets. We're going to have that memorized. There is, again, nothing. So there's nothing from Chapter 10, and there's really nothing from Chapter 12 also. That is on a formula sheet. All right. 1225. We're going to do this page last here. This is page 20. This is page 20 now. And it said, of people who died in the United States in recent years, 86% were white, 12% were black, and 2% were Asian. This ignores a small number of deaths among other races. Diabetes caused 2.8% of deaths among whites, 4.4% among blacks, and 3.5% among Asians. The probability that a randomly chosen death is a white person who died of diabetes. Okay, so that's it. What's the probability of selecting a white person who died of diabetes? Probability of selecting a white person that died times the probability that that death was by diabetes. Multiplicative property of probability. 1226 says, using the information in the previous exercise, the probability of randomly chosen death was due to diabetes. Was this? What is the probability of death by diabetes? This is what we just found out. Probability that a white person dies of diabetes, this probability that a black person dies of diabetes, and the probability, that probability that you select a death that is an African American who died of diabetes. And this is probability that you select a death of someone that is Asian that died of diabetes. All right. There you go. 030 would round to. 1227 says New York State's quick draw lottery moves right along. Okay. Players may choose between 1 and 10 numbers from 1 to 80. 20 numbers are displayed on a screen every 4 minutes. If you choose just one number, your probability of winning is that. Lester plays one number 8 times as he sits in a bar. What is the probability that all 8 bets lose? All right. So X is probability of winning number. Probability of X is 0.25, 20 out of 80. What's the probability? None of them are winning. So this is the probability of not winning, 0.75. We're going to raise that to the 8th power. It's only 100. We'll have to figure out how much you would win and how much the ticket would cost to find the expected value. All right, 1228 is a good one. I think we've seen something like 1228 also on a homework. People with type O negative blood are universal donors. That is, any patient can receive a transfusion of O negative blood. Only 7.2% of the American population have O negative blood. If 10 people appear at random to give blood, what is the probability at least one of them is a universal donor? So X is a person with O negative blood. The probability of X is 0.72. We divide 7.2% by 10. All right. So probability that X is greater than or equal to 1 is 1 minus the probability that X is 0. And that's the probability of not finding someone with O negative blood. It's 0.928. You're going to raise that to the 10th power. That would be 10 straight people not having it. 1 minus that is 524. So it's above 50% still if just 10 people walk in. All right. So what else do we have here? I believe we have 1230. 1230. Oh, then look at that. Tells you something. X is a portfolio that goes up in a year, so probability of that is 0.65. That's what it's saying. Okay. So what's the probability that goes up 3 straight years? Maybe 0.65 to the third. Then what's the probability? All right, so take your time, write that down. What's the probability that the portfolio's value moves in the same direction, either up and down for 3 straight years? So we want it up for 3 straight years, but we found that already. But the probability it moves down 3 straight years would be 0.35 raised to the third because it's 3 straight times. And then we get that. All right, folks, I'm looking at the grade book, and in order to have the exact same points in second quarter as we are going to as we had in first quarter, I need another little 5-point assignment, and you had one of those in the first quarter. Remember that? On a notes video at the end of the hour, I had you get out a separate piece of paper and turn that in, and all but a few of us did that. And you know, this is just a good way for me to check who's doing what they're supposed to do when I'm gone. You are in stats. You're supposed to be watching a stats notes video. All right, just because I'm gone does not change anything. You know, you'll have professors gone and TAs will teach, or they will literally bring out, you know, a video of something that they gave as a lecture in years past. I was in a lecture hall of like 200 people, and they busted out maybe like an old school video player to show that. Anyway, so yeah, I really want to see like who is actually trying to do all they can to do the best in this class. So get out a separate sheet of paper. Get out a separate sheet of paper. We have done this before. A separate sheet of paper with your name on it. I'll give this to you back because I'll give these back because these are also going to be good notes, but make sure your name's on it. All right. Write your name. And this was 11/20/23 notes video. This is going to be for 5 actual points. Okay, if you were gone on Monday, and I'm gonna check that with our system. Obviously, you still need to watch this video because you received it in your email by Sunday night, right? You're gonna have to email me either of these answers because you can, or you'll have 24 hours to get me this if you were gone. All right. If you're not gone and here and you missed it, you still want to turn this in, we will not get full credit, though, and we can save excuses. Okay, so what is the probability of A or B? All right, A union B, not intersection. So probability of A, probability of B, probability of their intersection is as follows. You can have those down. Probability of A plus B minus their intersection. 087, 087. So these are questions you'll see obviously on your chapter 12 quiz, and then that last exam before the final, chapter 10 and 12. So if I have the probability of A, probability of B, and I know probability of A or B, what is the probability of their intersection? So some very easy algebra. Probability of A or B is equal to probability of A plus probability of B minus their intersection. Probabilities can never be negative, nor can they be bigger than 1. So please don't give me those answers, because it's not a good error, all right? So yeah, 0.49 would be their intersection. Probability of A intersection B, or you can call it X in this situation. All right, and lastly, we have a Venn diagram here. All right, that was the second one. Make sure you have all this, so definitely pause it. You should still have time to get this in here. 200 people polled, so 123 like A, 100 or 97 like B, 68 like both. I don't know, something might be a candidate. All right, so we could start with the 68 that like both. So A, B, always put this, whether it's a name of a candidate or a name of a school or just A, B, and C, always put something here. So how many just like A only? 123 minus 68. How many just like B only? 97 minus 68. So there's people that are going to like neither, right? We're going to find that probability. So take 200, because 200 people were polled. 200 minus this plus this plus this. And I believe that's 152. So you get 48. So what's the probability that they like neither? 48 out of 200. That's the probability. Okay, so you got these 3 questions. Again, just wait. Last few minutes of class. Wait. All right, so you don't have to save anyone that's not paying attention. Okay. So turn this in to the top tray before you go. And there's some homework questions. So there's a bunch of homework questions here that we can handle. And definitely the first page, number 1 and 2, we can do those. And a lot of these that we're going to learn very early. Might even start learning some Tuesday or very early next week. And this is due December 1st. 1 and 2 for sure. And we might, we've done the signal question. So number 9, you can give number 6. You can do number 9 for sure. You can get 6, a very good attempt. I mean, honestly, you know how to do 10 and 11, but I can give you more examples of that. You know how to do 10 and 11. We've done one like 14. We literally just did one like 15. Okay, so you can do 14 and 15. You can do 17. You can do 18. You can do 19. And then I'm going to give you help on, was that, I guess, 23 and 24 on Tuesday. And then you can probably do 22 with no issue at all. So we're getting close to half of this. You can have done by when Thanksgiving break is over, possibly more. Anyway, that is it, folks. This is Yak Math Videos, signing out.